So even though everyone in the room, we've all said hello now already, but to all the people online, hello and welcome to our very last talk of Climate Week Northeast. Thank you for all of your support throughout the week. It has been very overwhelming. We've had over 170 people who signed up to the talks this week, and all of the talks will be getting distributed further. So if you've missed any and there's some that you want to see, then you can absolutely get access to them once all of the editing has been done. But it's my pleasure to introduce Ben Jurak today, who's going to be talking to us about what to do with waste and circular economy and about his business origin as well. So he's very kindly come over from RGU and Grace School of Arts. So without further ado, I'll hand you over. We'll have a nice Q&A at the end. So remember your questions, and anyone online, please feel free to type into the chat box and we'll ask Ben at the end. So thanks again.
Thank you very much. On hopefully. That's coming through okay for everyone online. So I'm Ben Jurak. I've got a background slide coming up, but loosely, I'm interested in talking today about the value of plastic, so not demonizing plastic, circular economies and sustainability. But I thought I'd start firstly by just introducing who the people are behind Origin. We're not medical practitioners. We don't pretend to be, very much designers. So we've got Daniel Sutherland, who's Associate Dean for Grace School of Art, founder at Origin, with over 20 years of experience in sort of designing commercial products. My name's Ben Jurak. I'm course leader for three-dimensional design at Grace, which is a course that combines product design with craft, so sort of a real sort of celebration of materials and processes, getting very hands-on. And then I myself also have 10 years of experience designing commercially as a product designer. I felt like I had to start with that slide as a bit of a caveat. So I'm 100% coming at this from the perspective of a designer. So I thought what I would do today is maybe just give a sort of broad introduction to plastics just generally. Talk about, I guess, the value that they bring within a healthcare setting. Talk about the environmental cost of plastics. And then finally finish up with what are circular economies and how can we use a circular approach to have a more sustainable future. So what is plastic? Plastic was first created over 100 years ago now, 1862-ish, although it wasn't really first commercially used until the early 1900s. So it's only really been in circulation for about 100 years. When we get into the volumes of plastic that we're talking about, hopefully that lands a little bit. So in terms of how plastic first came about, it actually was invented for environmental reasons. So it was back when we were using animal tusks, tortoise shells as a way of creating aspirational products. So it was introduced as a way of perhaps not taking out animals and having a more sustainable approach. However, as a result of what plastic actually is, so plastics are a class of synthetic materials made up from long chain monomers, polymers, and it's that plasticity that essentially makes them so moldable. And because they're so moldable, we've optimized manufacturing methods that allow us to produce them really cheaply. And because of that moldability, we can essentially transform them into near on anything. So far and wide reaching. But fundamentally, plastics have pretty much been behind every technological jump that we've had for the last 100 years and are really, for me, sort of core technology in terms of democratizing access. When you think about some of the biggest technological breakthroughs that we've had, I'm sure you could all think of loads within a medical setting. But one of the ones that really jumps out to me is the telephone. So if we think about when the telephone was first invented, the only way that we had that ability to communicate to each other was through accessible pricing. So that meant that we needed a product to exist in the world at a price point that we could all access. As soon as that was possible, the whole world became connected. We haven't really looked back since. So just a really quick introduction to where plastics came from. But in terms of types of plastics, this is where things get a little bit confusing and murky. So we're all familiar with these recycling symbols down here at the bottom, and these all represent thermoplastics. So there's two types of plastics. You've got thermoplastics and we've got thermosets. And I've divided it up here to try and represent the split in terms of the way that those plastics are circulated. So 20% of the plastics in circulation, they're thermosetting plastics. So they're essentially a plastic component and a catalyst. Once they're mixed, it's an irreversible chemical reaction. So think of it sort of bread into toast. You can't turn toast back into bread. So those are the plastics that are really don't offer us very much potential in terms of recycling. So they're things like wind turbines, toilet seats, or the nice soft grip that you find on your toothbrush, or the sort of soft hard grip that you get on the end of a pot or a pan. Then we've got thermoplastics. So these are polymers that become soft when heated, which allow us to form them and reform them many times. So we're talking about things like utensils, plastic bottles for storing of liquids. We're talking about large objects like garden chairs or children's toys. All of these plastics, however, are different types of plastics. And that means that we cannot mix them together. So it's really important that we separate and we segregate, which is why we've got the recycling symbols, and we'll get on to how effective they actually are. But this is a bit deceiving because it looks as though there are only 7 types of plastic. The irony is number 7 is actually other, which accounts for hundreds of plastics. So I've got an engineering handbook at home with pretty much every type of plastic and all of its properties, so that from a design perspective, I can make sure that I'm choosing the most appropriate material for the given task. The other in here, I would anticipate you would find a lot of that within a healthcare setting. Typically, this is your engineering plastics. So as well as having the likes of, for example, let's imagine you've got a Coke bottle here. So a Coke bottle is actually made up of 3 different types of plastics. You've got a PET bottle, you've got a PVC wrap around it, that's what they would print onto, and then the top is HDPE. So even within that one plastic product, there are 3 types of plastics that would need to get segregated to stand any chance of being recycled. But on top of that, so take PET for example, that exists in many forms across many products. They all have different needs. And so as well as having the core plastic within a molding process, you can also incorporate additives. So things like UV stabilization so that the product serves a better life in an outdoor environment, or you might add some additives for strength. So even though you might end up with one stream of plastic, they're all entirely different because of the way that they're made up based on the additives that they used, whether it's for color or performance. So just to try and sort of set the stage in terms of the complexity that we deal with plastic. So it's a benefit in the sense that we can mold it, we can manipulate it to be essentially anything that we want it to be, but that obviously has drawbacks later on. So in terms of why plastic is now so prolific, this is a pretty standard factory that you would find out in the Middle East, Far East. Each one of these, so this is an injection molding machine. So pretty much every item that you've got in here, so like that cup lid that you've got on the cup there, that would be a silicon. So that would be a thermosetting plastic. And that would go through an injection molding process. Easiest way to think of it is imagine taking that part, taking a block of aluminium or steel, and then creating a cavity, cutting the tool into as many parts as it needs to be so that it can open without the part getting trapped. Often 2-part, 3-part. And then that silicon cup lid there, in terms of one of these machines, the mold itself would probably be about this big. It would probably be 10 cavities. So for every injection that you do, you get 10 of them out. The injection cycle for that part was probably about 35 seconds. So every 35 seconds, we're introducing another 10 of those on this scale within one factory. So I think it's really clear how we can see how much plastic is being introduced into the world. And obviously that has the benefit of democratization in terms of access, and obviously all of the innovation that we've seen really over the last 50 years. But the reason why it's so prolific is because we've got low production costs because of optimization in terms of factory setups like this. Plastics are really high strength when you've got high strength to weight ratio consideration. Their flexibility, this isn't in terms of how flexible they are, it's flexibility in terms of molding. The fact that we can make a tool and essentially injection mold pretty much any form we want nowadays. So huge flexibility across pretty much every industry you could possibly imagine. They're really lightweight. So for example, you'll always hear the argument of why don't we go back to glass milk bottles because we can reuse them. the implication there is the supply chain that's involved in actually delivering that. So if you imagine that we swap from plastic to glass, suddenly we're probably 10xing the weight, which means that that's going to have an implication on that supply chain and the carbon involved in terms of actually delivering that. So there's all these considerations. So the fact that it's lightweight is one of the reasons why we see plastic being so prolific, especially in single-use plastics, in terms of cutlery, takeaway tubs, all that kind of stuff. It's also highly sanitary, obviously within a healthcare setting. That's a really important factor. And then finally, its versatility. So those factors combined is why plastic is so prolific. And I think I have to apologize for this next slide. No, not quite. Okay. So what I thought would be worth doing just really, really quickly, if I give you 20 seconds, if you just think in terms of your own practice, a single day, if you had to name 5 plastic products that you interact with on a daily basis, if I give you 20 seconds just now, see how quickly it takes you to think of 5 products. Do you all get to 5 pretty quick? Yeah. So if I gave you any other material, I think it would probably take longer, which just goes to show how prolific plastic is. Obviously, plastic isn't bad. I know as healthcare professionals, I wouldn't need to convince you of that. There is a perception in the wider public, obviously, in terms of how plastic is being portrayed through the media. It's being portrayed as a very sort of black and white argument. We know that's not true. It's way, way grayer than that. So just really quickly, some of the examples that you were thinking of, I would anticipate that they're all used as a means to save lives in some capacity. So just really quickly, if we take a couple of examples. So example 1, face masks. Obviously, when COVID hit, we had this massive proliferation of single-use face masks that suddenly entered the market, and the speed at which that happened was phenomenal. So how effective they are, I wouldn't know. I'm not a scientist, I'm a designer. But the speed at which we're able to deliver that in terms of scaling up production to meet demand is largely as a result of how lightweight it is and how low cost it is to deliver. So we've got a solution that can obviously be flat packed. We can get thousands into small areas and very quickly distribute that on a global scale. That in combination with when you first get it, it's completely sterile, safe to use. And then obviously it has been designed in a specific way to respond to a specific task. Example 2, incubators. So obviously incubators are used every single day as a means to keep people alive, babies in particular. And so for me, looking at this as an outsider without any technical understanding of what's required here, clearly plastic offers a sterile environment. It's a lower cost solution than other materials, which means that we've got an ability to have more of them, more impact. In terms of performance, I would anticipate the fact that they're clear allows for ongoing monitoring in a much, much easier way. Its thermal properties, its ability to sort of maintain humidity and heat, I would anticipate is probably an important factor. And then finally, interaction. The fact that we can have a combination of flat panels with injection molded areas to actually carry out the interactions that you need without necessarily introducing more harm, all make plastic probably the best material that you could use in this scenario. And then finally, yeah, that flexibility in terms of enabling that through different manufacturing processes. So all your white areas here, these are probably all injection molded. Your flat panels here, they're probably extruded and then possibly laser cut or die cut. And then final one, caveat here is my wife is a dietitian. So she wouldn't let me have an example that wasn't dietetics focused. So we've got feeding tubes here. And again, they're sterile, cost effective. A lot of the elements used within here are single use to ensure that they are sterile. In terms of performance, plastic's also a really brilliant material to use within a healthcare setting because of its comfort or its ability to offer comfort through that ability to mold plastic in any way that we want to be able to deliver that functionality. And in this instance, we can produce tubing, for example, that is flexible and we can change. So flexibility from a design engineering perspective is known as shore hardness. And because we can chemically manipulate plastics, we can get anything from the softest silicon you've ever felt all the way up to obviously the most rigid plastic you ever get and everything in between. So that plastic there will have been spec'd to exactly the flexibility that offers the performance that's needed. So just a really quick recap in terms of what we've covered so far then. Hopefully it's clear how plastic has been a vehicle for enabling significant improvements, specifically within a healthcare setting. As I say, I'm not a healthcare professional, but I could quite happily look at a multitude of different industries and find a multitude of examples that demonstrate the same thing. So we know that plastics save lives and that plastic as a material isn't inherently bad. So this is the apology. So what's the problem? So this will make sense in a second when you see the next slide. This is the only photo that I have of me when I was 3. Thank you, Mum and Dad. So back in 1992, let's have a look at the scale of plastic growth and plastic waste over a 30-year period. So back in 1992, we had 1.8 billion tons of plastic that had been produced, which equated to about 100 million tons annually. And if we were to take all of that plastic and lay it up to our knees across an area, we'd basically be filling up half of Scotland. That's how much plastic we have at that point. This is where it makes sense. So this is my son, 3 years old, last year. So 2022, 30-year gap. What's the difference? We've now got 9.5 billion tons of plastic that has been produced to date. That's now 380 million tons annually. And the most shocking statistic is that only 9% at that point had been recycled. The bit that I didn't tell you in here is that of that 9.5 billion tons in 2022, over 8 billion tons was considered waste. So moving on, if we follow projections, 2051, when my son would be 30, we would have 26 billion tons of plastic that has been produced if the forecasts are to be believed. We're then at a point where we're producing 800 million tons annually. So you can see that logarithmic scale. And again, if we take all that plastic and we distribute it across a landmass, we've now got the UK and its islands, we've got the Republic of Ireland, we've got Germany, we've got the Netherlands and Belgium, all full of plastic up to our knees. So it's quite a lot of plastic. So if we actually take a step back and we look at that volume of plastic and the impact that it's having on our environment, plastic does biodegrade. There's a bit of a fallacy around there. Obviously, there's lots of talk about bioplastics that obviously biodegrade. All plastics biodegrade. The problem is plastics biodegrade. Synthetic plastics that are petrochemical in their source biodegrade over hundreds of years. So in terms of how that specifically impacts on climate change, we know that plastics break down over time, and as they break down, they introduce more greenhouse gases into our environment, adding to climate change. They also pollute our waterways. Apologies for the shocking image, but I know we've all seen images like this a lot. So they pollute our waterways and are one of the main causes of marine species extinction. There's no reason why this bird should be consuming this plastic. There's no reason why that plastic should be in that bird's environment. And then we've got microplastics. So again, I'm not a scientist. I'm not going to profess to any of the data that's coming out, but we do know that plastics break down, and we know that they break down much faster when they get into waterways. So some of the biggest culprits for microplastics are perhaps from sources that you wouldn't even think of. So we see stuff like this, consumer products, and that's what we think of when we think of plastics in the ocean. But one of the biggest contributors, there's two of the biggest contributors to microplastics in the ocean. Number one overtook number two a couple of years ago is tires. So tires from our cars. Obviously the rubber's constantly wearing, that's breaking down, that's getting pulled away into our drainage systems and ultimately ending up in our oceans. Number two is our clothing. Most of our clothing that we're wearing today is plastic based. Every single time we run it through a washing machine, that's agitating our plastic clothes. Obviously, clothes are made from small fibers. That's agitating it, turning it into microplastics, which again, drained away into our waterways. And we're starting to see studies emerge that are showing, the most shocking one was that we're seeing microplastics in the placenta with unborn babies. What the impact of that is, I don't know. But there is nowhere on Earth where scientists have not found waste plastic. So even in terms of where we are today, if we imagine ourselves on that same trajectory with the volume of waste that we were looking at in my previous slide, we can sort of anticipate where this is going. So that's the environmental cost. So yeah, again, just quick overview in terms of what we've looked at so far then. So we know that plastic was an innovation that initially set out to tackle environmental causes, however, is now one of the largest contributors. We know that it's a material that is essentially wondrous in the sense that we can chemically control it to do essentially whatever we want, and we can heat it up and we can mold it to be essentially whatever we want. And as a result of that, in combination with it being a low-cost manufacturing process, we've got a proliferation of plastic. Plastic isn't bad, it's simply used badly. So the fact that of that 8 billion tonnes that I spoke about earlier, it's estimated that 50% plus was used for less than 15 minutes. So it lasts hundreds and hundreds of years. Most of it was used for less than 15 minutes. So it's not that plastic as a material is bad, it's that we use it badly. So what options do we have? What can we do? So option one is we could look at new materials, things like bioplastics, and absolutely where there's an opportunity, we should be using bio-based plastics instead of petrochemical-based plastics. That's quite a simple one. However, there is a little bit of a grey area in terms of what is a bioplastic? Is it compostable? Is it industrially compostable? There's loads of mixed messages that are going around. There's a lot of greenwashing. So this here is a knife and a fork that I had from Vegware that literally says compostable. It doesn't say anywhere on it that it's industrially compostable. It does on their website, but as a consumer, this is my only interaction with their product. It says compostable. So I put it in my compost 4 years ago. And when I had a look at it, when I showed my students this slides 3 weeks ago, that was it 4 years later. Like, it's not compostable, it's industrially compostable. We don't have a huge amount of industrial composting facilities around the UK. The other challenge is you need to obviously make sure that that goes into a composting bin for it to be able to get collected and ultimately industrially composted. But European studies have shown that even if we do that, it uses 95% more energy to industrially compost plastic than it does to simply recycle it. So why are we making new plastic when we've got 8 billion tonnes of waste plastic? That's the origin argument. So again, plastic alternatives, you'll see lots of stuff like this around that has really strong sustainability messages. So this is a really classic example, but there's hundreds out there. So this is a company that produces coffee cups for cafes made from coffee husks. So a waste material from processing coffee beans. In itself, entirely compostable. Leave it in the ground and it will compost. What they don't tell you is that they can't actually just use coffee husks. It needs to become a composite. So they need to mix it with a material that will hold all the husks together. So the bit that you won't find on their website is that it actually uses over 50% polypropylene as their binder. So you're not drinking from a coffee husk, you're actually drinking from a plastic coffee cup with a bit of coffee husk in it. The problem is that we've got these sort of conflicting messages. And actually, as a result of doing that, composites are probably the worst kind of materials from a recycling standpoint. So we've now got a material that was entirely biodegradable on its own, if left to its own devices, and a recyclable plastic. But by combining the two of them, we now have this mix that we can't separate. So if we heat that back up, we have no way of pulling the husk back out of the plastic. So as a result of that, we've actually got an unrecyclable material. So this is where the circular economies come in. This is still a linear model, which we'll get into in a second. So it's great that they're using a waste material. It's great that they might be using a recycled plastic. But what about the end of its life? And that's when we come to recycling. So at the moment, we live in a take, make, waste economy, which is a linear economy. And that is essentially where, even though organizations might be talking about recycling, they're not actively involved in the delivery of that. We know that the recycling system is imperfect. So this really isn't being considered. So this is where a circular economy comes in. And a circular economy is really about closing the loop. It's about stopping waste from being produced in the first place. So this is back to my original argument of, if we've got 8 billion tons of waste plastic, why can't we use that? Why do we need to create any new material? So I'm not sure if anyone's seen this before. A couple of you. So when anyone talks about the circular economy, front and center is always the Ellen MacArthur Foundation. So for anyone that's interested in circularity or the circular economy, go to the Ellen MacArthur Foundation's website. It's a fantastic resource, constantly being updated with uplifting news about positive change that is happening, because it can seem quite depressing. But there are a lot of people out there trying to do better. But they developed the butterfly diagram is what they call it. And it essentially shows you what a circular economy should look like. So this is the foundation for any starting point of anything that should be introduced into our world. And it starts with exactly the same sayings as we were taught when we were growing up. So reduce, reuse, recycle. And the reason why we say them in that order is because that's the order that we should be doing them in. So first is reduction. So how can we reduce waste? Reuse. So you can see here, obviously, if at the end of its life, we can reuse it, it ends up further down that supply chain. If we have to go all the way out to recycling, that's having to go all the way back to the start, and it's then having to go through all of the supply chain. At each point, there's logistics, there's obviously carbon involved in the delivery of that supply chain. But it's based around the 3 key principles. So it's about eliminating waste and pollution. That's its core value. It's about circulating products and materials at their highest value. So for example, I'll explain what origin is in a second. But if someone approached us with a children's toy, for example, that was in perfect working order, we would not transform that into one of our products. Our starting point is actually reusing. So where possible, that's what we should be doing, is using the products at their highest value. And then finally, it's about regenerating nature. So 3 key principles with a diagram that the more time you spend with that, the more helpful it becomes. But fundamentally, it's about closing the loop. So we've got 8 billion tons of waste plastic. What if we just recycled it? What if we just made use of the stuff that we've got instead of pushing it under the carpet? Well, even if we did do that, so let's take an example in terms of what happens. And this is part of the problem, is when you take your single-use plastic item or whatever you've got and you put it in a recycling bin, do any of you know what happens to it? No, like I don't know what happens to it. That's part of the problem, is that circular economies are they're too big to understand. I think everyone's kind of wish cycling at the moment. We put it in the recycling bin and we're like, I've done my bit. And we're hoping that something good happens to it. But we know only 9% of it has been recycled. So circular economies are so large that even if plastic is recycled, it has to travel around the planet to do it. And this is, again, one of the founding principles as to why Origin exists, is even if we can do this, and even if this is what we're doing, we don't think that model's good enough. Because the one thing that you'll see is anytime there's any sort of carbon accounting, so when the UK talks about the fact that it's not one of the world's largest contributors to climate change, when they're doing their carbon counting, they're not accounting for any of the supply chain in terms of, like, we're not a producing economy. We're an importing economy, but we're not accounting for all the stuff that's made out there. And we're not accounting, certainly, for the supply chains involved. So again, let's take an example. So let's say we take a water bottle and I put it in the recycling bin. That gets collected by local recycling, ends up locally in Aberdeen, that'll get sorted, packed up, and then it'll end up on a boat. And I'll show you in a second what happened to that plastic a couple of years ago. Let's just imagine it is on its route to getting recycled and turned into a new product. So it then ends up on a boat. It probably ends up somewhere that the UK has a deal with, typically out towards the Far East. It'll get broken down, shredded into that. At that point, we've got a feedstock that we can reintroduce back into a manufacturing process after it's been cleaned and processed. Then it ends up back on another boat. It will get shipped across to somewhere like China, maybe India, as a way of getting remanufactured into, I don't know, a new pair of recycled sunglasses. At which point it then gets packaged up, put on another boat, sent back to somewhere like Germany as a sort of distribution centre. And then at that point, I order it and it ends up back at my door in Aberdeen. So what I don't think about as a consumer is that journey that it's been on. I just think about the fact that I'm using a recycled material, and that's great. So it's brilliant that we're doing it. We're not doing it enough. And even when we're doing it, we don't think it's good enough. So the one missing piece of the puzzle that quite often is left out is transport actually accounts for 16% of global greenhouse gas emissions. That's one of the largest segments of the pie chart. Obviously, most of that is probably commuter travel, but a lot of that is logistics in terms of getting stuff around the planet. So for us, we think circular economies are too big, which leads to systems that are opaque and lacking in transparency, which is why ultimately, I don't know about you, but certainly for myself, I find myself feeling disappointed in it and not necessarily trusting in the fact that when I put something in the recycling bin, something good will happen to it. And it leads to stories like this breaking. So I'm not sure if anyone saw this story break. When was it? 2021. So the UK had an agreement with Turkey to, I think, take about 50% of our plastic waste. The UK doesn't have the facilities to recycle. So we sent it off to Turkey. From the UK's perspective, we signed that off. That's been recycled because that's what we've paid for. Turns out it was getting burnt and landfilled. So it was not getting recycled. And this is part of the problem, is that they're just too big to understand. So right now, we don't know what's happening to our plastic waste. And that's where Origin's approach came in. Oh, I forgot about this slide, apologies. So I'll get to Origin in a second, but one of the other issues that we've got is, as I was saying, the language that's being used by organizations relies on a perfect system. But we know that the system isn't perfect. So it's unhelpful when we've got companies like this that talk about a summary on how to recycle nutritious plastic products. So again, this is feeding tubes and related products. So the fact that it comes with a recycling symbol doesn't tell us it's getting recycled. It tells us that it's technically possible to recycle it. When you get to number 7 and other, that's got a recycling symbol, but most of those are unrecyclable. So it leads to stuff like this happening. So sustainability claims that are getting made, but ultimately it's telling us that this bottle is made from polyethylene, and it's telling us it's widely recyclable, and it's telling us that if we dispose of it in our household plastic wastes, it will get recycled. So it is unhelpful that we have these sustainability claims, because it leads to perception around what's happening. So this is why we invented Origin. So for us as designers, with about 30 years of experience designing plastic products, pretty much every designer goes into design because we want to have a positive impact on the world by the products that we bring in. The reality is that we're not the decision makers. So whilst we might push for more sustainable options to our clients, ultimately that's not a decision that we get to make. And we were finding that we were getting a bit fed up of basically waiting for the world to do something. So we came up with Origin, that we started in 2019, as a means of decentralizing plastics recycling. So the ambition is to have a network of decentralized hubs delivering microcircularity. So we're all about microcircularity, because if we can do it on a micro scale, it means that it can be transparent, delivered in front of your eyes, with the ultimate ambition being that we have an origin hub in a city centre, so high footfall, so it's about as transparent as you can possibly get. And so that you as a consumer, when you just pass by, you can see every single step of that process so that you, as a member of the public, have confidence in that recycling system. And if we can scale that up around the world, there's no need to collectively ship plastic waste around the world because of that decentralized model. So the ambition is, so in terms of what we do at Origin, this isn't actually our hub, it looks a bit different to that. We did have a little pop-up in the city centre just before Christmas, which was fantastic. Brilliant to be able to have the conversations that we did with the public. But essentially what we're talking about is we've got a space for donation of waste plastic. So things like that. We've seen enough of those. And then it's really simple. So from that point, we need to separate by colour. And then we'll granulate the plastic, so we'll shred it, big fancy shredder. We'll have to break down the plastic a little bit before we do that. And then from that, we've got our individual colours that have all been shredded that we can then mix to create our colour combinations. And then we use a manual injection moulding machine, which doesn't quite give us it doesn't quite give us a part every 35 seconds. It's more like 6 minutes. So it's a much slower process. But one of the signifiers of our products is we want a consumer to be able to pick up our product and know that it's recycled. So the way that we do that is all of our products have a marbling. And so we'll control those color combinations to try and create aspirational products. But the ambition is that we're doing the exact opposite of what the last 100 years of injection molding has done within industry. Within industry, it's all been about standardizing and homogenizing outputs. We want consistency, and obviously within a healthcare setting, that's really important. What we're about at Origin though is sort of trying to introduce an aesthetic that is polar opposite to what is being done currently on a mass production scale. Because the way that we produce our parts is technically impossible to do with an industrial injection molding process. So you will never see an industrially produced injection molded piece of plastic that looks like that. They're starting to simulating it, but they're not getting anywhere near. So as a member of the public, it means that if you see this in the world, that has been recycled. It's made from recycled plastic. So yes, it's about taking waste plastic and injection molding that into new and long-lasting products, but equally by putting it in the public eye, we're hoping that there's an opportunity for behaviour change. So if the public have opportunities to see what's actually involved in it and the effort that's involved in it, then hopefully that leads to positive behaviour change around the decisions that we make individually. There's a really famous quote to do with sustainability that I'm a big advocate of, and it's, we don't need hundreds of people doing sustainability perfectly, we need millions of people doing it badly. Or imperfectly. So an example of the type of work that we do at Origin, which I thought might relate in some way. So we've been working with Camp Hill School over the last 2 years. So obviously over the pandemic, they were regulated to use face masks in a particular way, which resulted in a large volume of waste, which they didn't know what to do with. So a face mask like this has not been designed for recycling. You can put that in your recycling system, but it will not get recycled. Fabrics are really, really difficult to recycle. So we basically worked with them to understand what is a face mask made from. So ultimately, most face masks are 3-ply, but all 3 of those plies are made from polypropylene, which is the plastic that we recycle at Origin. So that was a big plus, brilliant. It's got little nylon straps on the end, so we'll need to get rid of those, and it's got a little metal clip on the inside. So we processed 10,000 of those, but in terms of what was involved in that, that meant that we had to do this 10,000 times. And only at this point can I shred one of these through our shredder and injection mold it. To make one of these, so this has got a little bit of face mask through it, makes a beautiful marble by the way, but it takes 40 of these to make one of these. So you can see there that it's a massive amount of effort, We're a big advocate of the Scottish living wage, so everyone employed by Origin gets the national living wage. That's something that we can't escape, is the labour that goes into that. The reason why we can work with Camp Hill is because they'll process that for us. So actually we're getting them in this form. So at that point, economically it can stand up, because that's the other thing is, for all the best will in the world, unless it stacks up financially, people just won't engage with it, whether you're selling products or trying to put products into production. So if it's not as good and as cheap as what we've got already, then you're going to have a really difficult time actually changing the system. But yeah, so that's just a quick example of the type of work that we do at Origin, the aspiration that we've got, why we exist, based around the problem that we've got in terms of the imperfect world that we live in. So from, I guess, your perspective, hopefully that's been helpful in terms of the broad overview, but what can you actually do with that? So as I say, I'm not a healthcare professional, wouldn't ever profess to be. You're the experts, you're the ones that see these issues, opportunities on a daily basis. So what I wanted to finish with was actually just introducing a single design tool that we use as a way of understanding a problem in its holistic fullness, and then having a lens by which you can then test some ideas that you've got to see, does this idea stack up? Will it work? Is it worth me investing time into? And before I did that, I thought it was worth just doing a really quick intro in terms of the power of design, why we work in the way that we want. So product design is all about empathy. It's about understanding who you're designing for and placing them at the center. And I'm sure you can see parallels, therefore, between your patient-centered care approach as healthcare professionals. So this is a slide that I use all the time with my design students, stage one. And this probably makes you feel slightly differently to how my students might feel, but normal response to this would be slightly intimidating. So now imagine you're 5 years old and you've got to experience this. So this has been a huge problem within healthcare settings. It introduces massive costs because what they found historically is that the only way they can actually get the child to do what they want them to do is to anaesthetize them. And as soon as you do that, then you've got the ramifications in terms of they have a longer stay, which obviously has added cost. That across a huge demographic, obviously costs adds up quickly. So it was a problem, a design problem, and a couple of designers came up with some slightly novel solutions that wasn't in any way about redesigning the actual piece of kit itself. It's about thinking about the users, putting them front and center. And so one solution was that they had the sort of pre-MRI room where a child goes into, there's a mini version of it, and they've got these teddies, and the teddies can have little NFC tags that are put in. So for example, if this person was having a brain scan, they could put a little NFC tag in the head, and then the doctor or whoever it is that delivers that can basically talk them through what's needed. Child can see what the results are, so it's a positive experience. They then go into the MRI scanner with a much more positive mindset. The alternative was just to decorate the existing one and make it feel slightly less intimidating, make it feel fun, make it feel playful. And seemingly the results were so positive that children came out of this type of experience actually asking when they could come back. So it's about transforming by putting those that you're designing for at the center, taking a holistic approach and working within market and technological constraints. There's opportunities to surprise, delight, and deliver benefits to users. So within product design, we call that a human-centered design approach, and that is front and center at absolutely everything that we do. So what can you do? So there is a fantastic company called IDEO. They are probably the reason why we've got the words like design thinking. So within a business context, I'm sure you've heard the word design thinking. There's a lot of interest in applying design concepts in different ways. And IDEO have a website here. So if you go to designkit.org, there's a really good introduction into what human-centered design is, but they've also got a methods tab where they've got 50 different design methods, and every method is different depending on what you're looking to get out of it. So if it's about understanding users, rule number one is to understand human bias. We all know that there are a multitude of biases in the world. And so basically rule number one for most designers is don't ask, observe. And so this one is journey mapping, and it's really simple. So all you do is you've got a big straight long line, you've got an area under here, and the first step is actually just to map out every single touch point. So every single interaction with the product or the service that you're interested in that you think potentially has a fault that could be improved. So step one is just understanding all the touch points. And then usually this is through the lens of a user experience. This might actually be through the lens of potential for recycling. And so you've got indifferent, happy, sad. And then basically, as soon as you know all your touch points, you can go through each one of those and just decide whether or not that's a positive or a negative experience. Any opportunity that you see as negative, that's the opportunity that you can focus in on. And that's a way of understanding large, complex services, large, complex products. But it can also then be used as a lens to be able to put your own ideas through to see, is the solution that I'm thinking of actually better than what exists? So it's a really simple tool that you can use, but would definitely encourage you to have a look at designkit.org. It's a fantastic resource if you're in any way interested about anything that I've talked about. That's me.
Can I grab the mic then? Is that
Yep.
okay?
Oh, you might have to grab it.
Thank you. Thank you so much, Ben, for that absolutely amazing talk. Really, thank you very much. I think we've all learned quite a lot from that. It's really, really enlightening. I'm going to open up the room to any questions, anything that anyone would like to ask, and please do ask on the comments as well.
This might be stupid. Sorry. What's the barrier to the UK recycling its own stuff en masse?
Cost, probably. I don't have the answers, but for me, I think the biggest barrier is as long as it's cheaper to use virgin plastic than recycled plastic, there's no reason to use recycled plastic. So unless for me there's legislative change that perhaps artificially changes the price of virgin plastic so that recycled plastic becomes more competitive, then that might be the kind of incentive that then incentivizes innovators, entrepreneurs to begin to start to do that kind of thing. But yeah, it's a really tricky one.
Thank you.
Thank you. Thank you, Ben. That was really fascinating, really interesting stuff. Obviously, it's the plant pots that you have at the moment that you're managing to recycle or generate from recycled material. But are there limitations in what you can make? Does it depend on the sort of injection mold things that you have, and what's the scalability? How small could you possibly go?
Yeah, it's a really good question. So I guess there's lots of factors at play there. The reason why we actually developed Plant Pot as our first product was largely to do with what was within possibility at Grays. So we've got a lathe at Grays, lends itself nicely to circular objects in terms of machining the tool. But there's a whole heap of other considerations that we need to give weight to. So obviously regulations. We need to make sure that we are putting products into the world that are safe for use. So at the moment, that means that Origin's only in a position, largely from a funding perspective, to make unregulated products. So we can't be making, say, coffee cups. That's one of our most requested items. Obviously, that's food contact. We'd need to be food safe. If we wanted to do that, it is possible. But what we would need to do is we'd basically need to take a batch of our shredded plastic and then have it sort of recertified. But the cost involved in doing that doesn't stack up until you're big enough. Like the hub that I showed you, at the moment, we have an employee that is hand grinding and hand injecting sweat, blood and tears. As I say, one of those every 6 minutes. We have in the background, though, been working with one of the leading injection molding manufacturers. And there's some really exciting developments there where essentially we could take an Origin hub and we could have a machine about as big as this room. But we're talking 250 grand to be able to get that machine, plus specialist training. Tools become more expensive. But at that point, we can have impact on scale. So at that point, annually, we can do a ton of waste plastic now. that would mean that we could get up to between 11 and 15 tons. So at that point, yeah, we could be looking at smaller objects, because at the moment our limitation is hand injection. So that's as much pressure as we can inject into the mold. As soon as you're into industrial machines, we can be looking at 10 ton, 50 ton, 100 ton machines. A bit stronger than us.
Yeah. I think we have a comment that's come in online, so I'll just pop that up here. So do you have a waste management licence that would allow NHSG to supply you with some of our plastic wastes?
It's a really good question. So at the moment, we have a CEPA exemption licence. So we're actually exempt from some of the waste management licenses that would typically exist, which basically means that as long as we operate under certain conditions, so at the moment we are not allowed to take waste from organisations. It has to be donations from members of the public. I think within a research setting that would be possible, but yeah, at that point we're talking about a different scale. That's where we want to be. Obviously at that point we would have to have the full licenses in place. But
I see Emma Beaton typing in a wee comment, so we'll wait for that. But any other questions from the room?
Yeah. I was just wondering, obviously your products are designed to be to have longevity, but what is just because of the circular economy and stuff, can those be broken down and remolded, and would they, hopefully, they wouldn't ever need to be disposed of, but if they were, are they recyclable or,
how does it happen?
Yeah.
So yeah, as you say, we're pretty active on social, and if you have a look on our social feed, you'll see that a while ago we shared some of our design rules. So basically we've got a scorecard, and if a potential product doesn't meet those requirements, we won't put it into production. So one of those requirements is about longevity. But yes, inevitably they will have an end of life, and the ambition is as I say, it's about creating trust in our system. So what we would like to do as we scale up is actually sell each of our products with a prepaid mailing bag, so that if you do ever decide to dispose of an Origin product, you can actually just send it back to us free of charge, so that we can then obviously reprocess it. General rules of thumb is that you can recycle plastic up to 7 times. That's kind of untested though. But yeah, absolutely. All of our products are designed with sustainability in mind, circularity in mind. So you won't ever see us using glues or fixings with any of our products. The plastic element will always be isolated on its own.
Sorry. So if you wanted to contribute some plastics, how would you do that? And is there anything that you really don't want that would be a nightmare for you to get rid of if we gave it to you?
Yeah, it's a really good question. So obviously there's hundreds of types of plastics. We don't want to mix plastics, because we don't want to be in a position where we make a thing that obviously then can't be recycled. So at the moment we've got 3 rules. We can't collect from public organisations, private organisations, but as individuals you can donate plastic to us, as long as it's number 5, so polypropylene. So if there's not a number 5 on the product you would like to donate, we can't take it, even if we know it's polypropylene. We only accept clean plastics, so we have an ability to clean plastics, but again, that adds cost on our end. Collectively, that's something small that we can all individually do. And then finally, we can only accept white or colourful plastics, and that's purely down to aesthetics. When we try and make, so black is a really commonly used plastic, but it's a really dominating colour. So as soon as you introduce any other colours with it, it's just completely washed out by the black. And having tested it, it's just not as popular. And if we can't sell it, then we're not actually having any impact.
Keep seeing a comment starting to be written and then disappearing. It's interesting that you talk about the fact that at the moment you're only able to take plastic products that are donated on an individual basis, not able to accept any products that are coming from organisations, etc. But maybe there's that scope within a research setting to start doing. So are there any project ideas, or is there something that we can cultivate in the room?
We're 100% open to it. So I know that my colleague Daniel has had conversations with NHS, Grampian, with regards to research bids.
He's a grant actually with Daniel, but unfortunately it wasn't.
Oh, really?
But would very much like to sort of pick up the momentum in that again.
Like, that's what makes us tick. We want to be involved in those kinds of projects. Like, we operate at a scale and we're entirely vertically integrated, which means that we do every step of it. So that's what makes us tick as designers. We'd love to be involved in any projects that you've got.
Are there any particular plastics that you think it might be the easiest to start looking at? I mean, obviously, you're saying you can only take them in that 5 category, but are there any plastics that you're aware of that we're using? And obviously, with a dietitian as your partner, are you aware of any plastics that are being used that would be a good place to start?
So typical rules of thumb are plastic films, really difficult to recycle, so like the gowns and stuff. We'd struggle with that. Hard plastics, good plastics to recycle are polypropylene, number 5, and HDPE, I think that's number 2. Basically, if you've got either of those and you're interacting with those on a daily basis, depending on the life that they've lived, i.e. whether it's suitable for us to use it. When it gets into medical waste, I wouldn't know where to begin with that. But again, if there's opportunities to do anything with that and it's safe for us to do it, then we're happy to be involved.
With regard to things like face masks, like you said, that's obviously quite an intensive process to remove all of that. However, I'm thinking on scales of medical schools or even people like, nurses are walking around with scissors in their pockets anyway. Yeah. And I think it's quite an interesting thing for people actually have to be given the responsibility to break that down, because it just gives people a bit of a consciousness and an awareness that actually magic doesn't just happen. You can't just put something in a bin and expect something magical to happen. We all need to take collective responsibility, absolutely. So I think that's something interesting for us to all think. I think actually there was so much interesting stuff in that talk that all of us will have to take a bit of time to reflect and think about how we can...
if anyone wants to reach out to me, my email is ben@originmat.com. Feel free to contact me. It's really funny you talk about that though. So obviously that was one of the sticking points that we were having with Camp Hill, is that they really wanted to work with us. They really wanted to have a solution for their plastic waste, but it did come down to cost. Mm-hmm. So they needed to get some sort of saleable product out of it, ultimately down the line, for it to stack up with any longevity. Mm. So the challenge that we had was basically that we couldn't process the masks. They didn't have the capability to do it. So one of the things we looked at was, can we, as Origin and Camp Hill, design something that lives within Camp Hill so that workers, it's not a case of having to manually pull the bits out and have scissors to hand. There's basically something you would go up to, and then it's a much faster process, as opposed to having to, and then that would just be next to the bin that you would dispose of it.
Absolutely.
But it's about segregation. Like, if there's an opportunity to do that in medical school and you think there'd be an appetite to do that, like, I'd be happy to just explore what the potential might be.
Absolutely. But that's just past 1 o'clock. So what, I'll close it down to questions at the moment. If anything comes online and we're having a chat in the room, we'll get back to you. But just again, thank you so much to Ben for coming out to see us. And that's the end of Climate Week. So it's been an excellent week. Thank you so much for your support. Please do spread the word. Once we send out the talks, please do distribute them far and wide. Any ideas? The whole concept of North East Climate Week is really to create a network and empower people to make sustainable choices in their day-to-day lives and even the way we work in organisations. So please do keep in touch. If there's people, if you can get in touch with me and I can put you in touch with other people to try and make things happen, and especially with research projects to try and to start changes that then can hopefully be distributed even wider, then this is definitely the forum to do it. Within NHS Grampian, there's the Sustainability Network that you can join up to, which Dr. Sarkar spoke about in the Greener Theatres talk yesterday, so do look that out. And certainly within Aberdeen University, there are places you can work through as well. So please do get in touch if there is anything that you're inspired to take action on, and we can signpost you to the people to do that. So thanks again.
Cool,
Thank you.
The pupils at Camp Hill have a